In today's video, we're going to be talking about section 5.1, which is the systems of linear equations in two variables. So the objectives today are listed here. There are 5. Decide whether an ordered pair is a solution to a linear system. Solve a linear system by substitution and by addition. Identify systems that do not have exactly one ordered pair solution, and solve problems using systems of linear equations. So we want to talk about what is this linear equation? What does it look like? So I'm going to flip ahead first, just a second. This is called a linear system. So a linear system is an equation that is in the form of a linear equation, and there are 2 or more of them. It kind of looks like this. This is an example of one. So let's fill in the blanks on the previous page. So it says all equations in the form ax plus by is equal to c are straight lines when graphed. 2 such equations are called a system of linear equations, or a linear system. A solution to a system of linear equations in 2 variables is an ordered pair that will satisfy both. So very important, it has to satisfy both equations in the system. A linear system that has at least one solution is called a consistent system, and a linear system that has no solution is called an inconsistent system. So let's look at an example on the next page. It says determine whether the ordered pair is a solution to this system. So we're given an ordered pair here, 1, 2. This is my x, this is my y. So to determine if this is a solution to this system, we have to check it if it works in both. So what we're going to do is we will write out each equation. So here's my first equation, and here's my second. And then what I'm going to do is I have my ordered pair. This one, the first value in my ordered pair represents my x. So wherever I have a x in my equation, I'm going to put in a 1. In the second one, the second component of the ordered pair is the y. So wherever I have a y, I'm going to put in a 2. So I'll have 2x minus 3y, and I'm asking myself, does this equal -4? So 2 minus 6, doing the multiplication of each one before I subtract, keeping in mind the order of operations. Does 2 minus 6 equal -4? Yes, it does. So it works in here, so it's true here. So far, this is a solution. But we have to make sure that it works in both. In order to be a solution to a system, so this whole system has to work in both. So that means I'm going to go to my next equation, and in place of x, I'm going to put in 1, and in place of y, I'm going to put in 2. And I'm going to check if the 2 cents are equal. 2 plus 2, does that equal 4? Yes, it does. So it works in this one too. So since it is true in both, then I can say that yes, the ordered pair 1, 2 is a solution to the system. Now, what we're going to be doing is, besides checking if we have an ordered pair that is correct, but we're going to be finding what this ordered pair is. And so that's what we're going to use are next to the ways to solve the system, the next two objectives to do. But before we get to that, there is a problem for you to try. So I'd like you to pause the video. I'd like you to try this problem and see if this ordered pair that they give you is a solution to this system. So try this one, and then I'm going to restart the video and you can check your answer. So what I did, you should restart the video, and you should have seen that when you try it in the first one, you do get a true statement. But when you check it in both, in the second equation, the linear equation, you get a false statement. And so since it does not work in the second one, the ordered pair is not a solution to the system. And so that should be your answer. So you have to check it in both. So now let's move on and let's look at how to solve the systems in order to find those ordered pairs. So the first method we're going to look at is called substitution. So let's fill in the blanks here. We're going to solve either of the equations for one of the variables in terms of the other. If one of the equations is already in this form, you can skip this step. And I'm going to give you a hint. If you have to solve for variable, pick a variable with a coefficient of 1 or -1. It's going to make it a lot easier. If you have to pick something that's other than 1 or -1, then you end up with possibly fractions, and it makes it harder to complete. Substitute the equation you find in step 1 into the other equation. This will now result in an equation with one variable, and then you can solve the equation containing the one variable. And then what we're going to do is back substitute the value that you found in step 3 into the original, simplify and find the value of the remaining variable. And then you are going to check the proposed solution in both. So the solution you come up with should work in both of the given equations. And so that'll be the check to just make sure you did it correctly. So let's look at, here we have our system. This is our example. And so the steps I just gave you are written here. So we're going to perform the step that you see written. Solve either one of the equations. So which one am I going to choose? Well, you can choose any variable to solve for, but like I said, if you can have a variable that has a coefficient of 1 or -1, which I do right here, that's the one you should work with. So I'm going to take the second equation. My coefficient on y is 1, so that's why I chose it. And I'm going to solve this equation for y. So in order to solve this for y, subtract 2x from both sides, and now I will have this equation solved for y. Y is equal to 1 minus 2x. So I'm going to take this now, and I'm going to take it into, I'm going to say, here is what this is what y is equal to. And I'm now going to substitute this expression from step 1 into the other equation. So here's the other equation. It's the first one. And in place of y, I'm going to put the expression 1 minus 2x. So let's write that out. So I have 3x plus 2y, but instead of y, I'm going to substitute in 1 minus 2x. Now I have an equation that has one variable, and I can solve for that one variable. And if we go on to the next page, we'll have more room to write this. So we have 3x plus 2 times 1 minus 2x is equal to 4. So let's distribute this 2 first, and we'll get 2 minus 4x is equal to 4. And then I'm going to combine my like terms. Where are my like terms here? Well, on the same side of the equation, I've got these two that I can combine to give me negative 1x. And I'll need to pull over. I need to subtract 2. Remember, the goal is to isolate x. So subtract 2 from both sides to end up with negative x is equal to 2. And then I'm going to divide both sides by -1. And that will result in my answer for x, which is -2. So this is the value I get for x. Now, remember, this is not the end, because why? This is an ordered pair. That's just the value for x. So I have to continue on, and let me write the system up above here that I had in the original page so I don't have to flip back and forth. This was my original system. And what I did was I took this second equation and I solved it for y. And now I found that x is equal to -2. So I'm going to take the value that I found in step 3 and I'm going to back substitute it. So I'm going to take it over and I'm going to say, take in this -2 and I'm going to plug it in for the x. And I'm going to see what I get for y. So y, and I could go into either of these equations. This one I already have solved for y, so it makes it a little bit simpler to do. And so now I'm going to substitute in -2, and let's see what we get. Y is equal to 1 minus -4, or y is equal to 1 plus 4 minus a negative will be plus. So I get y equals 5. So the proposed solution is -2, 5. So I always want to have an ordered pair. Either I'm going to write my answer like this or in this ordered pair format. And then the last step would be to check it. So taking this next page, and let's check the answer we got. So the first thing I need to do is write down the two equations I had. That was one of them, and this was the other. And I'll go back to the originals to make sure I didn't solve something incorrectly. Just go back to the originals just to do your check. And so notice I'm putting blank spots in place of the x and the y. Excuse me. And so I am going to, x I found to be -2. So wherever I have x, I put -2. And then y I found to be equal to 5. So wherever I have a y, I'm going to put 5. And then I'm going to make sure that the two sides are equal. So I have -6 plus 10. Does that equal 4? Yes. +4 on both sides. So that's true. And then here, -4 plus 5. Does that equal 1? Yes. So it's true here. And so since they're both true, the solution here is -2, 5.